We are back algebra. 10-2C, simplifying radical expressions. So this is the last section that we'll spend on 10-2. We've had 3 of them. We'll move on after this to 10-3. So 10-2C. So now we are going to simplify radical expressions, and now we're going to use the quotient property. So the last 2 we've been dealing with the product property a lot. And if you remember, one of the things we said all the time in the last 2 sections was you cannot have a square root in the denominator of a fraction, and you can't have fractions in the square root. So let's look at what the quotient property says. First of all, in words, you might not like it in words because it's a lot of words and a lot of information, but we do it anyways. So the square root of a fraction is equal to the square root of the numerator and the square root of the denominator. So all that stuff, we say all that basically to say this in symbols. Those of you like this. So if you've got a fraction in the square root, you can basically break it up just like you could in multiplication. You can break it up or split it up and take the square root of the numerator and the denominator separately. So one thing we try to do here is just make sure we write the words split it up. Okay, just like kind of in multiplication, you could split up a product into 2 factors, or you could multiply them first and all that stuff. Rationalizing the denominator. So remember, a square root is not a rational number. So we have to find a way to get it to make it rational. And so we call this rationalizing the denominator. And basically, it's a method used to eliminate all radicals from the denominator. Because remember, there was a rule that we had that said you cannot have a square root in the bottom of a fraction or the denominator. Okay, so let's look at the steps to do that. The first step here is to break up the square root. So again, if it's a fraction form, then break it into a square root of the numerator over the denominator. If you look at your examples below, you can see that letter C is already broken up for you, but A, B, and D are not, and you'd have to break those up first. The next step is to multiply the numerator and denominator by the square root. There's stuff missing here. So let's go ahead and see if I can just get rid of this. It's supposed to say the square root of the denominator, but let's just say by the denominator. Okay, so you're going to multiply the top and bottom of the fraction by whatever's in the bottom. Okay, or in math terms, you're going to multiply the numerator and the denominator by the denominator. Okay, and then after that, you're going to multiply the radicands. Okay, and remember, remember the terminology, the radicand is the number inside, underneath the square root sign, or underneath the radical. And here, when we multiply these radicands, we want to keep the numerator and denominator separate. Okay, I'm going to keep those separate when we multiply them. And then finally, the last one is we want to simplify our answer. So simplify means a lot of things, okay? Simplify, just like we did in the first 2 sections where you can't have any perfect square factors. If you can break down the final answer, then do it, okay? So you want to simplify your answer. And then there's 2 ways to kind of think about that. Like we said, we could simplify your new radicands. That's one way. So whatever you get after you multiply, can you break down that square root further? Is there a perfect square factor that we can break down like we did in the last 2 sections? And the second thing you might now have to look at is to simplify the coefficients. Remember, coefficients are the numbers in front of the square root. So if you have to simplify your coefficients, and that might be in the form of, say, a fraction. Can you reduce the fraction or simplify the fraction? And we'll see some examples of that. So those are the steps in how we are going to simplify with the quotient property. Okay, so let's get some practice problems, shall we? All right, let's do letter A. So simplify says your answers may have a radical. We know that in the numerator, that's fine, and it may have one. You're probably going to, we, again, do not want decimals, okay? I know you can type this in your calculator and get decimals. We're not looking to do that. We're looking to break it down, okay? Okay, so the first step says to break these up or split these up. So because it's square root of 7 over 5, I can rewrite that the square root of 7 over the square root of 5, okay? Simple rule there says I can take the square root of both the numerator and the denominator. All right, now I cannot have this radical in the denominator. So what I'm going to do is I'm going to multiply the top and bottom by the denominator. Well, the denominator is the square root of 5. So I'm going to multiply the top and bottom by the square root of 5. And by doing this, I'm not really changing anything because we all know that anything divided by itself is 1, right? Anything as a numerator over the same denominator is equal to 1. So even this example right here, square root of 5 over square root of 5, technically is equal to 1. And so it's not going to change anything with the equation. It's just going to help us where we don't have anything in a radical in the denominator. Okay? So we can go ahead and continue on. On the top, square root of 7 times the square root of 5. Well, remember, we can go ahead and, with the product property, we can multiply those together and get the square root of 35. And down at the bottom, square root of 5 times the square root of 5 would be the square root of 25. And now we know also that on the bottom here, we know that the square root of 25 is 5. And so that would be in our denominator. And then square root of 35, there is no really way to break that down because there's no perfect square factors in there. You got, what, 7 and 5, 1 and 35, that's it. So that would be our final answer right there, square root of 35 over 5. And that is good because that 5 is not a radical in the bottom. Okay? Let's see. Let's skip over to part D here, or letter D. Okay. All right, letter D. So first thing we're going to do is break this thing up. We're going to split it up, and we're going to have the square root of 7x over the square root of 8. So it's using the quotient property. We're just going to split those two up. And now remember, we cannot have this radical square root of 8 in the bottom, so we're going to multiply the top and bottom here by the square root of 8. And some of you guys will pick up on a little shortcut here with the denominators. But as we keep going here, let's, I'm just going to shift this. Oh, we're good here. If I multiply here, 7x times the square root of 8, you're going to end up getting the square root of 56x. Because 7 times 8 is 56. You've got to bring that x along. All over, well, the square root of 8 times the square root of 8 would be the square root of 64. And then we know basically that we can, take that square root of 64 and turn it into an 8, because the square root of 64 is a perfect square, which is 8. So our denominator would be 8. And some of you guys are starting to see that connection here. If you multiply the square root by the same square root, it's just the number underneath the radicand. See, this square root of 8 times the square root of 8 gives you 8. Where back here, we had the square root of 5 times the square root of 5 gave you 5. That's always going to be the case. But if not, you can multiply it out and put the square root of 64, which then is a perfect square root of 8. Now, what do you do with this other one here, the square root of 56x? Because we can break that down further. Okay, so let's think about, do we have any perfect squares? Well, I know that the square root of 4 times 14 would be 56. So I could rewrite this as the square root of 4 times the square root of 14. And we can't forget that square root of x. Okay, so I could write that down. And then we know that, say, the square root of 4, we know is 2. And then the other one's the square root of 14. We can't break that down any further. And also the square root of x, we can't break that down any further because there's nothing times itself that will give us x. So 14 and the x are going to stay underneath the radical. And there we go. We've got 2 times the square root of 14x over 8. Now our one last step was to simplify our answer. We just simplified the radical of the square root of 56, but is there anything else we can simplify? If you look really close at this, we look at, say, this 2 and this 8. Okay, together, they're both outside the fraction, so they're both coefficients here. So we can simplify that. 2/8 would reduce down to 1/4. So it'd be 1 times the square root of 14x over 4, because 2/8 reduces to 1/4. Now, I won't need to write this 1 down all the time, but in this case, I just did here, but you could leave it out and just put square root of 14x over 4. Now, I do want to point out before we move on why I was able to reduce there in the 2/8, but we didn't reduce over here, okay, on this problem here. Okay, now I just want to point out, I know that 35 and 5 can go into 35, right? However, this 5 does not have a radical, or it does not have a square root sign, and the 35 does. So I have to keep them separate. I can't reduce, I can't divide into them unless that square root of 5, unless that 5 had a square root with it. So unless they're both radicals, then I can do it. If they're not both radicals, I can't. Or, I mean, I should say, if one of them's a radical and one of the other one's not, you can't reduce. So in this case here, I was unable to reduce because the 35 has a radical around it, the 5 does not. But in this example, the 2 and the 8 are both outside. They do not have a radical, so we could reduce those. Okay? So keep that straight when you're simplifying things as we go on. All right? That's it here. So let's go to the lesson summary. What do you multiply by to get rid of a radical in the denominator? So we kind of went through that step by step. What do you do? And then we've got a practice problem here. Simplify the square root of 2 over 6. And then be careful with this one because you're going to get an interesting situation to try and, when you are simplifying this radical, keep that radical out of the denominator. So simplify that one, and we'll be in good shape. Okay? So that is it on section 10-2C. Bring your questions with us. We'll be ready to roll.